This is Algebra 2, Day 2 of the workshop. What am I supposed to say? Don't forget to smash the like button, leave a comment, and subscribe. Was that all the 3 things? Oh, y'all, come on, y'all need to help me. Okay, there we go. All right, so we're on page 5, factoring polynomials. All right, we're going to follow the rules of PEMDAS, right? First, we're going to remove parentheses, combine like terms. If it is a quadratic, what does quadratic mean? Y'all remember? Quadratic is a polynomial that has 4 terms. We're going to work a lot with quadratics this year. A quadratic has 4 terms, but look how they have it. Really, it's lowercase levels and lowercase letters in most textbooks, so it feels strange for me to write it in uppercase letters until we get to pre-calculus. So I'm going to write it in lowercase. This is called the standard form. Normally, this is your 4th term, but they haven't set it equal to y. All right, so if it's a quadratic, quadratics are 2nd degree polynomials. I'm just going to write a quadratic up here. There are 4 terms in a quadratic, and you always write it in descending exponential form. That means your highest exponent goes first, and you go down from there. All right? When I have it in descending exponential form, then this is my lead term. Got it? All quadratics are 2nd degree equations. All of them are 2nd degree equations. All quadratics look like a parabola graph. They have 2 directions. It either decreases, hits its lowest point, then begins to increase, or it increases, hits its highest point, and then decreases. It's only, well, there's actually 2 other ways, which we'll get into in pre-calculus. It can open right, it can open left. But we won't do that this year. All right? But before we factor quadratic, it has to be in descending exponential form. All right? If I begin with a negative out front, I want to factor the negative out. So, factoring is really division. We're dividing when we factor. All right, so if I were to factor out the negative in this one, I would divide every term by a -1. Or I could just simply change every sign, and it becomes a negative on the outside, 2x squared minus 6x plus 3. Is your stuff on the table? Okay. All right. So we always want to begin with a positive lead coefficient. Y'all know that the 2 is the coefficient, right? That's what we call the number before the variable. -6 is the coefficient to that. This has no variable, so it's called a constant. All right? All right, so that's going to be important when we look at quadratics. Also, if this were like a 10, you would want to see, is there any value that can be factored out of every term? And because I changed it to a 10, I could factor out a 2 out of every term. And again, I would divide every term by 2. All right, so you want to factor out whatever we can out of every term before we begin factoring quadratics, all right? Now, that's step one. Always factor out a greatest common factor. So, if I had, let's just do this, 2x to the 5th plus 6x cubed minus 10x squared. Let's just make it descending. 4 and 3. All right, what can I factor out of every term? Yes, John. I can factor out a 2. What else can I factor out? Anything else? I can factor out a 2 and a what?
X cubed.
X cubed. So that my 2x cubed goes on the outside. And what am I left with for this first term?
X squared.
X squared. What am I left with here?
3x.
And here.
-5.
All right, so I always want, that's called factoring out the greatest common factor. Always with your variables, if the variable is in every term, you choose the variable with the smallest exponent, and that's what I'm factoring out. Make sense? All right, so look at step 2. If I have the sum of squares, they are not factorable. So, if I have like x squared plus 4, those are two perfect squares. What's the square root of x squared? X. What's the square root of 4? 2. That's why they're perfect squares. When we add two perfect squares, they are not factorable. You cannot factor them. The solution is actually imaginary. So, we have imaginary solution. Now, if I subtract two perfect squares, then it is factorable. And their factors, so the square root of x squared is x, the square root of 4 is 2. Their factors are called conjugates. You need to understand that word. So you use both of those numbers, but it's plus and minus the same value. Plus and minus the same value. I've seen on the ACT something like this, and they said, what is the conjugate? Conjugate simply changes the middle sign. So the conjugate is 3 minus 2i. Got it? If it were negative 3 minus 2i, and I asked you what is the conjugate, it would be negative 3 plus 2i. Only the middle sign changes for conjugate factors. Got it? So, if I had two perfect squares, are those two perfect squares? Right here.
Yes.
They are. What's the square root of 9x to the 4th?
3x squared.
It's 3x squared. So, you take the square root of 9, and you take 4 divided by 2 to get its square root, which gives us 2. All right, what's the perfect square of 16? 4. So my factors, if I were to factor that, it's my square roots, 3x squared and 4, 3x squared and 4. One is plus, one is minus. They're conjugate factors. Make sense? Got it? We're not going to do sum and difference of cubes. We will do that this year. But we're not going to do that today. All right, now, let's go to page 6. We're just going to look at the greatest common factor that we can factor out on page 6. Seth, can you share
Share what?
your page
Oh, yes, ma'am.
so that Locke can see? I have 2 Lukes in geometry. Oh, goodness gracious. Okay. All right, Locke, what can I factor out of that first term?
You want everything or just one thing?
Everything.
Okay, well, you can factor out the n to the power of 7.
Okay. And what else?
3.
Okay, here's something I want to lock in your brain. If my original expression has 2 terms in it, when I factor a value out, I'm still going to have 2 terms inside the parentheses. If my original expression has 3 terms to begin with, when I factor out inside my parentheses, I'm still going to have 3 terms. Okay? So as many terms as I begin with is how many terms I'm going to end up with in the parentheses. Makes sense? And the signs don't change, the plus or minus. All right? Now when I factor out the 3 into the 7th, what am I left with, Locke?
2.
2. And my second term, what am I left with?
5 n.
5n. So that's the answer. 3 into the 7th times 2 minus 5n. Does that make sense? That's how we factor out the greatest common factor. What did he do? He looked at the 6 and the 15 and said, what's the largest number that goes into both of those? The 3. Then he looked at the ends and he chose the lowest exponent and he factored that out. So lowest exponent. All right, let's jump to number 4. All right, Seth, look at number 4. Negative 3n minus 9n cubed. All right, what can be factored out of both of those terms?
3n.
All right, do I want to leave the negative on the inside of the parentheses? The answer is no.
No.
So I'm taking the negative with the 3n. So I'm going to divide every term by negative 3n, negative 3n. Inside the parentheses, I'm still going to have 2 terms. Outside, I'm going to have 1. What's outside?
Negative 3n.
Locke. Don't give him the answers. Negative 3n. I want his brain, not yours. Okay? Negative 3n. And what's on the inside? What's the first term?
Negative 3n.
No.
Negative 9n. 30 squared or cubed. I don't know.
John, what's left in this first term?
3 in the square.
No. Drew?
1.
1. Okay, everybody look. Right here. Negative 3n over negative 3n. Anything over itself is 1. Anything over itself is 1. That equals 1. Anything over itself equals 1. This is, I'm about to use a double negative. This is not nothing. It is 1. That's why I said, if you begin with 2 terms, you have to have 2 terms inside parentheses. You want to say there's nothing left here. I factored it all out. I haven't. I've got to have a 1. Okay, now what's left in the second term? Drew?
3n squared.
3n squared. Got it? Got it? I'm about to go over rules of exponents. We're going to memorize rules of exponents. Okay, let's go to number 6. Number 6 is negative 4b plus 4. Oh my goodness, I love this marker. All right, Ben, help me. What are we factoring out?
-4.
Correct. Negative 4. All right. What goes on the outside? Okay. What's my first term?
-4.
B. What's my second term?
-4.
-1. Got it? All right, let's go to 8. All right, Aaron, what am I factoring out? N squared, yes. All right, what goes on the outside of the parentheses? N squared. What goes on the inside? First term. 2n, second term.
1.
Plus 1. All right, let's go down to number 14. All right, Lily. What can we factor out?
-36x.
Well, I can't take 36 out of 4 or 24.
-4.
Does 4 go into all of them? Yes. Okay, so I'm going to take out a -4. All right. What else? It's like a 3 to the wolves, huh? By giving you this really hard one.
X squared.
Okay, can I take an x squared out of this one?
No.
No. You're always choosing the lowest exponent. So I can only have, there's an x there, x squared, x. So all I can take out is an x. Can I take y out?
No.
I can't because it's not in the first one. All right? So it's going to be -4x, and I'm going to have 3 terms inside. All right, what's left of this first term?
X.
No x. 9. There, and then it's going to be a plus. Then what am I left with?
Y squared.
Well, I have 1x, and then I have a y squared, and then,
6.
I know, y'all are at a disadvantage because I'm a lefty. 6
Y cubed.
y cubed, yes. All right, now we're going to go to number 20. All right, Rain. What can be factored out of every term? 7 and x squared and y cubed. Yes, goodness, I didn't do a very good job of writing that, did I? All right, so we have 7x squared y cubed. I'm going to have 3 terms in the middle because I started with 3 terms. And what am I left in the first term? X cubed minus 3y plus 2. Are y'all getting this? All right, so do 24, 25, and 26 on your own. 24, 25, and 26 on your own. Here, you can do them there. Mm-hmm. All right, Blythe, what did you factor out of number 24? Would you prefer me to call you Ribby?
Either one is fine.
Either one is fine. What is preferred? Ribby. Okay. It might take me a little while, but I'm going to work on it. Okay, Ribby, what can I factor out of number 24?
10x squared y.
Wait, let me get a better marker. We're gonna throw that one away. All right, 10x squared y. What am I left inside the parentheses?
3x4 y4
Okay.
plus 5x3
Uh-huh.
plus 2 close parentheses.
Everybody got that?
Yes, ma'am.
Excellent. 25. Leah, what did you factor out?
7 and to the 7th power n.
Did anybody take the negative out? You could have, or you didn't. Did you check the negative out? You didn't. Okay. You could have. And you should if it's a quadratic. All right? And what's left with inside?
Negative 10 n to the power of 3 minus 3 n plus 9n.
So your signs would have been negative, positive, positive, negative. All right, because in math, in your higher levels math, in your higher levels of math, we don't like those hanging negatives on the very front end of a polynomial. That's why you always factor out the negatives, and you'll see that throughout the year. All right, 26. Madeline, what did you factor out of 26? 2x3? So you didn't factor out the negative either? 2x cubed. Okay. And what's left on the inside?
4y plus 8.
So you did factor out the negative? Okay, if you factored out the negative, the first term is positive. So 4
4y plus 8x.
y squared, right? Is 4y squared your first term inside parentheses?
Yeah, it's just 4. But I definitely did it wrong.
It's y squared, okay? So if the first one's plus, the next one's minus, what do you have here? 8x, yes. Then the next one's minus, and you have 3y. There we go. Everybody got it? All right, move to the next page. It says factoring trinomials. These are quadratics because it has that fourth term that you don't see, which is equal to the y value. All right, so let's work through one together. All right, it's an ax squared plus bx plus c format. That's called standard format. There are I feel like there's 4 forms, but I can only recall in my brain 3 forms for a quadratic. Standard, S, and the other. Okay, vertex. All right, so x squared minus 14x minus 15. What's the value of a in this quadratic? 1. The value of b?
14.
Negative 14. And the value of c?
Negative 15.
Negative 15. We looked at this yesterday. When I factor, I'm looking for factors of a times c. So 2 terms multiplied equals 1 times negative 15 or negative 15. Factors, I'm always asking myself these 2 questions. Factors of a times c such that the sum, that means sum in math, sum of the factors equals the b value. So that if I add them, it equals negative 14. All right, you're always asking those two questions. So, what are factors of negative 15 such that I add them, the result is negative 14? Yes, Drew?
1 and negative 15.
1 and negative 15. Always with quadratics that have a lead coefficient of 1, which is called a monic term. Your first term in your binomials with factoring is x. This is your second term, and the sign goes with it. Plus 1 minus 15. We're going to set them eventually equal to 0 and solve. Because when y is 0, we have our x-intercepts. When x is 0, we have our y-intercept. When y is 0, we have our x-intercept. Let's say that. When y is 0, we have our. When x is 0, we have our y-intercept. Okay? Got it? A quadratic, are y'all focusing right here? A quadratic has one and only one y-intercept. It always has one y-intercept. Always. But in terms of x-intercepts, it can have 0, 1, or 2. At most 2, because it is a second degree equation. But it can have no x-intercepts. It looks like a parabola. All right? That's why we factor trinomials, so we can solve for the x-intercepts. This one has 2. If I want y to be 0, then I can make this term 0, make x equal to negative 1, which makes this term equal to 0, and 0 times negative 16 is 0. If I make x positive 15, it makes this term equal to 0, and 0 times 16 is 0. So I get my solutions. These are called by different names. They're your x-intercepts. They're solutions. They're roots. They're zeros. All these terms mean the same thing. And I'll say them all year long because I see we will use them. When we get to calculus, we'll look at them as zeros. On the ACT, oftentimes you see the word roots. X-intercepts is a very important concept used in all of your higher level maths. Some textbooks will say solve, give me the solutions for this, and this is what it's looking for. Got it? So all 4 of those terms mean the exact same thing. All right, let's look at number 2. X squared plus 3x minus 10. X squared plus 3x minus 10. What 2 questions am I asking myself, John, to factor that? What are factors of?
What are factors of A and C?
And what's A times C
A times C.
in this specific equation? What's your A value?
A value is 1.
1. C value.
Negative 10.
What's 1 times negative 10?
Negative 10.
Negative 10. So multiplied equals negative 10, but, and, not but really, and, what's my second question? Added equals what?
And that equals
We've already used A and C. The only one that's left is B. So added equals what? What's the B value? 3. All right, so help me think. John, what? multiplied gives me negative 10, but added gives me positive 3.
5 and 2.
5.
and negative 2.
Yes. 5 times negative 2 is negative 10. 5 times negative 2 is positive 3. My factors are x plus 5, x minus 2. Got it? All right, look at number 3. X squared plus 5x plus 6. All right, Ben, what am I asking myself? Factors of
6.
such that I add them and the result is? So what is it? Multiplied equals 6, but added equals 5. 3 and 2. So what are my factors?
X plus 2.
Okay. Doesn't matter what goes first.
Yeah.
X plus 2 times.
X plus 3.
Okay, can I quickly check this? Yes, like we did yesterday. My first terms multiplied have to be the first term. The last terms multiplied is the last term. My middle terms are the outers plus the inners. Okay, it's easy. All right, so x squared, first term, 6, last term. Add 3 and 2 times x is my middle term. Got it? All right, number 4. X squared minus x minus 42. Sam, you help me. Okay, factors of what? Negative 42. Multiplied gives me negative 42, but added gives me negative 1. Those signs go with it. Okay? All right, what multiplied gives me negative 42, but added gives me negative 1. You got this. They got to be close together because it's got to be negative 1. One's got to be positive, one's got to be negative. Because when I multiply, I've got to get a negative number. So we know one's got to be positive, one's got to be negative. And they got to be 1 unit apart. 7 and 6. Which one's positive? 6. And negative is 7. So my factors are x plus 6 times x minus 7. All right, let's jump down to number 8. (11n plus n squared plus 18). Can I factor this like it is? No, what do I have to do, Leah? Put it in standard form. My n squared has to go first. A, and I don't like that they use n. We will always use x because when we graph them, it's x, y. N plus 18. All right, Peyton, what questions am I asking? Multiplied gives me 2 numbers multiplied gives me 18, and added equals the b value. 11. There we go. That b value. What multiplied equals 18, but added equals 11. 9 and 2. So my factors are x plus 9 times x plus 2. Got it? All right, let's jump down to the first one under number 3. Okay, it wants us to factor this. But do you know how to factor this? Okay, Locke, what do we do?
You divide everything by x.
First, I'm going to factor out my greatest common factor. And I can take an x out of each one of these. This is not a quadratic. This is a cubic equation. It does not look like a parabola. It looks like this. So I'm going to have 3 terms multiplied. So I'm going to factor out an x. I'm left with x squared plus 6x plus 5. Now I want to factor what's inside the parentheses. Locke, help me. Factor what's inside the parentheses.
X squared plus 6x plus 5.
Okay, I want to factor what's inside. The x squared plus 6x plus 5. What are factors of? Factors of?
That would be 1 and 5.
So factors of?
Factors
Of what? Multiplied equals what?
5 times 1.
5. Added equals
6.
6. And it is 5 times 1. Got it? All right, look at the third one. Negative x squared plus x plus 20. Drew, should I do anything to this before I think about factoring it?
You could factor out the negative.
I absolutely want to factor out the negative. So I'm going to divide every term by -1. And I'm going to make it negative, make that positive, negative, negative. All right, help me factor what's inside the parentheses. So it's factors of
Negative 1.
negative 20 such that we add them and the result is?
Negative 1.
And what is that?
4 and negative 5.
So 4 and -5. Always factor out that negative. All right, makes sense? All right, let's move on to page 8. Graphing lines. Do you remember how to graph lines? All right, we graph lines on the Cartesian coordinate system. All right, let's look at number 1. I'm probably going to graph them different from the way you've learned to graph them. But this is how we will do it in algebra. What's the format of this equation? Well, first of all, what kind of an equation is this?
The slope. No, that's
Point slope.
It's a what?
Point slope.
It's not point slope. We're going to learn that this year. It's the slope intercept. So this is slope intercept, but you did say the name of one of them, but it's slope intercept, which is y equals mx plus b. What does the m represent? Slope. And what does the b represent?
y-intercept.
The y-intercept. It's intercept, not intersect. However, it is where that is, it's a linear equation. It's linear. Linear equations are first degree because they only have one direction. They only go in one direction. We read graphs left to right. We never read them up and down. Never. Never read top to bottom, bottom to top. We always read left to right. And next year you'll understand why that is such an important concept. The slope gives us an idea of what a graph should look like, what the line should look like from the left to the right. If the slope is positive, what does the line do from left to right? The slope is positive. The line rises. So, a positive slope, the line rises. So it's always going to look like this. Left to right, it rises. If you have a negative slope, then the line falls. It falls from left to right. Okay? All right, so we begin by graphing the y-intercept. Okay, this is an important concept. I said it earlier. The y-intercept is where the graph crosses the y-axis and the value of x is 0. So at the y-intercept, the value of x is 0. Got it? Y-intercept, x equals 0. Y-intercept, x equals, say it. So what do you think the value of y is for your x-intercepts? On an x-intercept, y equals 0. Got it? All right, so this really gives me a coordinate point. 0, -2. So that's what I plot. This is my x-axis. This is my y. That is 0, 2. Now, from geometry, how many points determine a line?
Infinite line.
2 points determine a line. Do y'all remember that? From last year. See, I told y'all were going to remember some stuff. So I need another point. And I'm going to graph the slope. It's the rise over the run. So I'm going to rise 7 as I run 2. If that's -2, you have to label your graph in my class. If an unlabeled graph doesn't tell me anything. You could be counting by 5s, you could be counting by 100s, you could be counting by halves. And I would not know it unless you label your tick marks. All right? So I'm going to rise 7. 1, 2, 3, 4, 5, 6, 7 as I run 2. There we go. That's another point. 2 points determine a line. Now I can graph it. So what did I do? I began with my y-intercept, and then I graphed my slope. All right, let's do number 2 together. Y equals -6x plus 3. Y equals -6x plus 3. Where do I start graphing?
+3.
At my y-intercept at 0, 3. 1, 2, 3. That's 3. Then where do I go? What's my next step?
You go up 6.
Is my line rising or falling? It better be falling.
Go down 6 and over 1.
Yes. Always write a 1 over your whole numbers. That's right. So I'm going to fall 6. 1, 2, 3, 4, 5, 6 to -3. My fall 6. Run 1. And graph the line. All right, everybody graph 4 and 5. 4 and 5. We're going to come back and do 3 and 6 together. your neighbor, make sure you look right. There we go. Those are segments, not lines. A segment is between two endpoints. These are not equations of segments. These equations are equations of lines. They go in both directions from negative infinity to positive infinity. Negative x infinity to positive x infinity. Negative y infinity to positive y infinity. That's why we do the arrows. All right, now let's do 3 and 5 together. What's the slope of number 4? Somebody tell me the slope of number 4.
6/5.
And what's the slope of number 5? 1/4. All right. Now, these two look different, don't they? Yes, they look different because they're not in y equals mx plus b format. So how can I tell? Positive slope, negative slope. How in the world can I tell? Well, they're neither. Both of these are neither positive nor negative. All right? I could rewrite number 3 as y equals 0x minus 5. I could rewrite it that way.
We're supposed to do 3.
We're doing 3 now. We're doing 3 and 6 together. All right? And so this is the value of y never changes. It is always, not positive 5. It is always negative 5. Every point on this graph is always negative 5. Every point. It is a horizontal line. Y equals a number is a horizontal line. The slope is the rise over the run, or it's the change in y over the change in x, or it's y2 minus y1 over x2 minus x1. If I had 2 sets of coordinate points, I could pick 2 sets of coordinate points. I could pick negative 2, 5, and 3, 5. And I could substitute it in to calculate the slope. Let's make one set sub 1, the other set sub 2. We did this in geometry last year. Y sub 2 is 5 minus y sub 1 is 5 over x sub 2 is 3 and x sub 1 is negative 2. Minus a negative is a positive. So it's 0 over 5. What does that equal? 0. So anytime you have y equals a number, you're always going to graph a horizontal line, and the slope is always 0. Always. Now let's look at x equals 5. On this line, there's no y. We could write 0y, but it makes 0 sense to do that. Every point on this line, what's the value of x?
5.
It's always 5. Every point on this line, x is 5. Here, x is 5. Here, x is 5. So let's take this point, 5, 5, and we'll take this point, 5, negative 5. And let's calculate the slope. We'll make this coordinate point set 1, this coordinate point set 2. Y sub 2 minus y sub 1 over x sub 2. Let's pick a different point. I need to make a better, let's pick, -3. Let's pick 5, -3. That's x sub 2, y sub 2. I need to make a better point. All right, so we'll do -3 minus 5. It would have worked either way, but okay, I'll show you why. It will look different. All right, x sub 2 is 5 minus 5. What's the numerator? -8 over what? 0. What does that equal? Do it in your calculators. See what you get. What'd you get?
Error.
Got an error. 100% of you should have gotten errors unless you did it wrong. This is why. That's -8 divided by 0. -8 divided by 0. If I did long division, what can I multiply 0 by to get to -8? Nothing. This is undefined. Okay, so this is one of the most important concepts in all of math. When the denominator equals 0, it is undefined. The term is undefined where the denominator is equal to 0. When we get to pre-calculus, we cannot graph a function where the denominator equals 0. We're going to have asymptotes because it's undefined. So a denominator in a rational expression, a ratio of numbers, the denominator value can never equal 0. Even if it is that. That is not 1. That is undefined. Because if I did long division, what can I multiply 0 by to get to 0? Every number that you could think of, I can multiply by 0 to get to 0. There's not one number, right? It doesn't have one solution. It is undefinable. So even 0 divided by 0 is undefined. So every horizontal line is y equals, and the slope is equal to 0. Every vertical line is x equals a number, and the slope is undefined. Got it? Undefined. Undefined 0. Undefined 0. Got it? All right. Look on page 9. How much time do I have? About, what time is it? 4:35. We have 10 minutes. Okay, we're almost there. Okay. Let's just quickly go through 1 through 6. Tell me, is the slope positive on number 1? Yes. We could go end to end. So that would be 1, 2, 3, 4, 5. So that would be 10. I'm rising 10, but I'm running how many? 3. So it'd be 10/3. Does everybody see that? Does everybody see that? Okay, you go end to end. 2, is it positive or negative?
Negative.
It's negative. You can't go end to end. You have to go like to that. Right here. You have to start right here. So I am falling how many?
3.
As I run, how many? I'm falling 3 as I run 9.
10.
I think I'm running 9. 1, 2, 3, 4. I got to start here. Look. Right here. Yeah, so I'm falling 3 as I run 9, so it's 1/3. Got it? All right, what is the slope of number 5? I'm sorry, number 5, not 3. 5. Undefined. 6.
0.
0. All right. Let's move on. I need to get to some more stuff today. All right. Variable worksheet. Go to number 11. I've got to get to... Actually, let's jump to 13. We're going to come... Word problems is where we're going to start in algebra, so I want to go back to 12, but let's do 13. I want to cover the rules of exponents. All right, before we leave today. We've accomplished a lot, not as much as I would like to have, but this is actually where your textbook starts, is rules of exponents, all right? We will start in lesson 2. All right, there are... What is the rule if I have something like this?
Combine.
Combine what?
Combine the like terms.
Okay, are they like terms?
Yeah.
They are. So what am I combining?
We combine 3x squared and 6x squared.
So what does it equal?
9x squared.
I'm combining what? What are these called? Coefficients. I'm combining the coefficients when I'm adding or subtracting like terms. And like terms are terms that have the exact same variables raised to the exact same exponents. Okay? Now, what if instead I did, how's that different?
They'll be multiplied.
Now I'm multiplying. I multiply the 6 and the 3. But what do I do with the x's now?
Add the exponents.
Yes. So multiplication to exponents is addition. Multiplication of terms is addition. So that's going to be one of my Miss Haleyisms. Multiplication is addition. Multiplication is, and it's going to be the same rules for logarithms when we get to logarithms the second semester. All right. So I add 2 and 2, it becomes 4. So multiplication is addition. What do you think division is? It is. Those are inverse. These are inverse. Got it? So I'm just going to use variables. X to the 5th over x cubed becomes 5 minus 3. Okay, what if instead
X to the negative 5.
okay, I could write it as x to the negative 5, 2 minus 7, or I could write it as 1 over x to the 5th. Yes. I do not like what your textbook does. It says make all exponents negative, make all exponents positive. Yes.
So how did I feel like when I was talking about it?
Thank you. Yes, yes, I did. Okay. So division is subtraction. Okay, what is that? What is this, ladies and gentlemen?
X to negative 9.
It's 2 minus negative 7.
So it's
X
to
9.
X to the 9th. All right, division is subtraction. Multiplication is addition. A power raised to a power. So, a power raised to a power. That's how I'll write that. A power raised to a power. We multiply. So it's like x to the 5th cubed. We multiply 5 times 3.
50.
X to the 15th. So, multiplication is addition. Division is subtraction. Power raised to power, we multiply. Well, there's one missing. Add, subtract, multiply. Which one's missing? Divide. It's when we have radicals. So when we have a radical, we're going to divide. The This is your numerator. That's your denominator. So it's x to the 5/3. What is that? X to the,
Third.
before you simplify,
X. 6/2.
right, which is x cubed. If there's nothing there, it's a square root. Don't call this a square root. It's a cube root. Don't call this a square root. It's a fifth root. What is that? X to the
11/5.
11/5. Okay? There's just two more things I need to show you, and we're done. What is x to the 0 power?
1.
What is that?
1.
Anything to the 0 power is always equal to 1. Let me tell you why. Because let's just look at this. It's because division is subtraction. It's as though we have this 3x squared y cubed over 3x squared y cubed. And when we subtract them, what's our exponents? 0. That's what this really looks like. It's this over itself, which is 1. Got it? Okay, one more thing. What if I have something like that? Okay. Normally, if I have a negative, I move it to the denominator and put 1 in the numerator, but it's a fraction. So I could look at it as 1 over 2x squared over 3y cubed and make the exponent, only the exponent outside the parentheses changes to positive. If any of these are negative inside, it doesn't change. However, I can flip the fraction on the inside and change that to positive because that's the same thing as this. And make that positive. Now, every term is raised to the power in the numerator and denominator. So 3 squared is
9.
y cubed squared is
1.
power raised to power we multiply. All right. 2 squared is x squared squared. Got it? All right, we'll stop there.